Let's get into the image sizing issue. So what we wanted to do is address the question, are three image sizes enough for responsive web design? This is typically one of the questions that we get when we talk to people who have responsive web design sites. They think that they're doing a great job by just doing these three resizings for every image on their site, and the performance is improved. Is that enough? Why is image? What we'll do is we'll walk through some of these questions. Why is image loading performance important? What are some of the standard practices today around these three images, or the techniques that people use to deliver images? Then we'll get into some research that we did about how device diversity and all the different types of devices that we're seeing today, what does that imply for the different types of images and image sizes that you need? And most importantly, we'll get into, okay, if you go the next step beyond these three images, what sort of impact do you have on the payload and the performance? We'll talk about some of the myths and realities that are out there, and finally we'll look at automatic resizing and how it works. So why is image loading time important? Well, images account for about 64% of a page's payload. If you look at a website today, we've got some data here from HTTP Archive, and they have measured this over several years, and 64% of any given, or the average website, is images. That's huge, and it's growing over time. People are continuing to put up larger and larger images, hero images as they call them, that kind of go across the banner. And also of note is the red bar here, scripts, JavaScript. Increasingly, JavaScript logic is taking up more and more of the website. And all of this means slower load times. Even though for mobile devices the bandwidth and performance is getting better, it's important to users. Payload is directly related to loading time, and 40% of people say that on a website, regardless of device, they'll abandon if it takes more than 3 seconds to load, which is a pretty quick response time that's required. So images are probably the biggest bang for the buck that you can take if you can address this problem. And the chain of logic that goes here is that device intelligence, this optimized payload, mobile optimization, it all means that you'll load your pages faster, and you'll get a better mobile experience, which will lead to more conversions and increased profits or improved results. That's the chain of logic that is important to accept, that this is an important issue for people. So let's look a little bit and talk about what the standard practices are today for mobile devices in the responsive web design area. So let's talk about image resizing. And Jan Arne, I'll invite you to jump in here and give a little more technical detail. So there's kind of three ways that people treat and handle images today. One is they'll resize for each form factor, the desktop, the tablet, and the smartphone. They'll use a technique called lazy loading, and in some cases they'll deliver things via a CDN, which pushes the images further out in the network to the edge of the network for quicker response time. So Jan Arne, why don't you give a quick overview from your perspective about what are the standard practices today around some of these three?
Sure. Yeah, I can do that. It's the vast majority of sites out there today still serve images the traditional way, with this one fixed size for any kind of device. Luckily, web developers and people in general are more aware of the issues by doing that. So in terms of image resizing, there are a couple of approaches that are sort of under that that umbrella. You can pre-resize, or if you have your CMS to do like 3, 4 different sizes of the image before you sort of publish the page. That's one option, and have either responsive images tags handle the image selection, or by some JavaScript, or of course you can do it dynamically like ImageEngine does. We'll return to that a bit later though. Yeah, but both these sort of techniques can be combined with lazy loading. Lazy loading too is in general, or in theory, I guess, a good thing. You shouldn't load a resource until you need it. The downside is, of course, that in most cases you're either breaking the preloader functionality in the browser, or you're downloading an image resource twice. The preloader in the browser works the way that once the browser has downloaded the HTML, it sort of scans through for all external resources, including images, and immediately opens a connection to download as early as possible. But with lazy loading, or some implementations of lazy loading, it's you're breaking that, because you're not necessarily providing a URL in the image source attribute, because you don't want the browser to start downloading the image, because it's most likely wrong size anyway. So you're waiting until the browser has downloaded the document and all the JavaScript, and then the JavaScript executes. And at that time, you know pretty much everything about the size and formats and stuff, and you can start requesting images.
And
so
that's usually just to clarify. So when you do that lazy loading, when the JavaScript does want to do the image, they've done a media query to look at the size, and they've created a breakpoint. Is that?
No, yeah, you can use media queries or media query-like functionality too in JavaScript. But yeah, usually you would look at stuff like the size of the browser window and that kind of stuff, and maybe even calculate the exact size of a smaller portion of the page where an image should be put in, that kind of stuff. With CSS media queries, the preloader would still work, but then of course you have to first download HTML and then download the CSS file. So there's a sort of a punishment there too. Yeah, and for CDN is also a very good thing. Of course, it offloads your origin server for a lot of traffic. Problem is that traditionally, anyway, CDNs have been sort of a dumb file storage. Even though some of the leading CDNs have implemented some logic for optimizing images and stuff, it's yeah, not so many developers know how to use that, and it's quite a heavy task. It involves many layers in the organization, not only the developer but maybe also the DevOps team, and yeah, it's a huge thing. And also, it's usually not automatic. It's very tempting to introduce yet another JavaScript to actually help with image selection, even on a CDN. But yeah, also some CDN supports like parameterized commands on how to optimize and resize the image in certain situations. But it's all yeah, there are good and bad things about all this. But yeah, still images is quite it's quite a hard thing to get right, as we'll see in a minute.
Great. So yeah, one of the things we did when we started to do the research here was we posed the question, are three sizes enough for responsive web design? So what we did is we see through one of our products requests for thousands of URLs for images. And we identify what sort of device is coming and asking for that image, and we know the size that is required to optimally deliver a image that will fit on that device and the optimal size payload. So what we did is we looked at the history that we have seen. We plotted out some of the results. And one of the things we saw right away was, this idea of three different image versions, one for laptop, tablet, or smartphone. It only takes about 8 requests these days in order to get enough to get the requirement for 3 different image sizes. And moving on, it takes about 200 requests to have the need for 13 different image sizes. Now, here we start to kind of, what we're doing with the 13 is we're breaking each one of those form factor categories into, finer and finer elements based upon the screen width or the screen height. And then finally, it starts to asymptote there at the top, but by 1,000, we get about 22 different image versions with different dimensions. So this really tells a very interesting story that 3 images doesn't really get you to an optimal solution. It does do some performance improvement, as we'll see, but if you really are a website that is concerned about the mobile web experience and performance, you might want to start thinking about your how many times you want to do this. So the important question is, okay, so this might be a lot of work for me, getting beyond 3 images. What are the payload savings? What does this really get me? Well, we set the control as the one full-size image. Like this would be a full, let's say, 500K image. That will be our 100%. So we assume that we would be delivering this if in the absence of any sort of resizing. With the rendering for 3 different image sizes for desktop, tablet, and mobile, so this is the industry standard that you'll see in responsive web design, it actually cuts a fair amount of the payload. About 63% of the original size is delivered. So you get a big improvement there. That's pretty good. And but the question is, if you follow that curve that we saw previously to resize to basically an automatic point, perhaps beyond the 20 or 22 images, what does that get you? What we've assumed here is that you provide that automatic image resizing based on the dimensions, but in addition to that, you might be optimizing for different formats. So if you're delivering to an Android device, you could use Google's WebP format, which is an even more optimized format than PNG or JPEG. So you get more effective compression around that. And even using a product like ImageEngine, if you're going from a JPEG to a JPEG, we might provide a more effective way of compressing that. But the point there is that compared to the 100%, you can get it down to about 16% of your overall payload. That's an 84% improvement over the original size of the image payload. It's a lot of performance that people who are only doing 3 versions are just leaving on the table. This is a huge bang for the buck to address the issue of image resizing. So let's kind of just quickly readdress some of these myths versus realities. I think what we were looking at was the three images. Are these enough? And I think the answer is, if you're concerned about performance, then no, this is not enough. You can get a big leap in payload reduction and web performance by using an automatic resizing approach. Lazy loading, does it really improve the experience? Well, I think the question here is exactly how you're doing it, but Jan Arne, what are some of the downsides of lazy loading once again?
The downsides are if you're breaking the preloader in the browser. That's the huge mistake to do. You should always provide an image URL in the HTML so that the browser can start connecting to the server and start downloading as early as possible. As long as you do that and think of lazy loading as load images or load resources on demand, or when they're needed, then you're actually then it's a good thing. Then you're not wasting bandwidth. So it's a slippery slope, but in general a good thing as long as you're not breaking the preloader in the browser.
Right. And I think with infinitely scrolling pages, I think lazy loading might make sense. But if you've got a relatively compact web page with a limited number of images, that sort of lazy loading approach probably is, and breaking the preloaders is probably not the way to do it.
Yeah, that's great.
I think some people they assume that CDNs provide automatic resizing, and some people aren't too clear on it. But in general, what we see is that CDNs they might have some resizing approaches, but they tend to be automatic in the sense that you give it one large image and it'll generate 40, 50 different dimensions. But it's not really clear how and when you would grab different size images. It's a bit of a shotgun approach.
Yeah, and it's a bit of a black box. So as a developer or a site owner, you really lose control.
In content management systems, once again, I think this gets back to the three images. A lot of them will resize 3 times and kind of use standard breakpoints. Is that correct?
Yeah, you have to sort of decide upfront, how many images and what sizes you want to create of the image, which is again an okay approach, but we never know what's going to happen in the future, right? So if suddenly you need a new image dimension, which is completely different from the ones you already have, you have to sort of regenerate, go back in time, go back in history of all your articles or stuff you published, and then regenerate the new size, which it's not unlikely to happen. It has happened many times before.
Well, yeah, and I think a great example is the iPhones. We'll get to that in just a couple of minutes. Here is the drastic increase in the size of the iPhone screens over the last 2 years is a point at which a lot of those breakpoints probably needed to change. So whatever we see today, we can be sure that a couple years from now we'll probably need different breakpoints. So why lock yourself in to that? Then finally, client hints. I think a lot of people are starting to learn about client hints and the capabilities it provides, and they're saying, well, doesn't this solve the problem for me? What's your understanding? Can you give us a quick idea of what client hints is, and what problems does it really solve, and what does it not solve?
Yeah. So client hints is basically, or put simply, it's the browser is sort of hinting to the server what size is the optimal size of a given image. And it's currently only supported by Chrome and Opera, the Blink rendering engine. So it's not supported by all the desktop browsers or mobile browsers out there. So what ImageEngine does in addition to supporting client hints is to, of course, use device detection by Woeful to sort of fill the gaps of client hints. Still, even with client hints, you would need the mechanism to actually do the resizing and optimization of the image.
Right.
Doesn't help you if your images are stored on a CDN, static sizes on a CDN, for instance.
Right. Right. Okay. So just a quick overview. We've alluded to the fact that there's this ImageEngine product. Well, what is it? It combines three things. It combines the Woeful device detection that ScientiaMobile is known for. It combines it with the automatic image resizing technology that we've developed, such that once you know the mobile device, you can adjust the width or the dimension of the device and crop it, and do a lot of different parameters if you want to take greater control. And then finally, there's a content delivery network associated with this, so that you can cache the image, and on subsequent requests for a device of the same kind, we don't have to re-render or resize the image. It's already there waiting to be delivered very quickly to the device. The way it works is pretty straightforward. In a image today, you'll see image source that you'll refer to at jelly.com/breadpng, and in the future, if you want to use ImageEngine, you'll keep that same full-size image wherever it is, and all you do is insert a token that you'll get from the ImageEngine service, and insert it into that image source as a prefix. And if you want to put in optional manipulation parameters, you can put that in between that. But a lot of people just leave that out and let the intelligence of the ImageEngine service provide the best picture. The benefits of this is that you get about a 60% savings in your development time. So you don't have to manually resize all these things. You don't have to create responsive image coding to set breakpoints or CSS. You get accurate and optimal resizing. You get a 60% performance in payload. That's one of the things that we've talked about here. It varies from device to device and site to site, but 60% is the average that we see. We're very scalable. The ImageEngine product delivers billions of images per month, and we have various features, including the automatic resizing, the file compression. We support HTTP2, client hints, and WebP. And there are various fit methods that you can use as optional parameters to make sure that the image is appearing the way you want to. If you want to test your own site, you can go to the demo that we have at imageengine.in, and it will provide a quick breakdown of the savings you would see on your site if you deployed ImageEngine. Here's an example from Eddie Bauer, where in one case they had an image that was 758K, which is a pretty big hero image. And for mobile devices, we were able to shrink this down to 106K. So, 600K savings on a single image is quite impressive. And Jan Arne, why don't you talk a little bit about the various ways that you can implement this? We have a lot of plugins that you can use.
Yeah, it's very easy to start using even without any plugins. It's just a matter of sort of prefixing your existing image URL with a token and the hostname that you get when you sign up for ImageEngine. For convenience, we've made a couple of plugins for the most popular frameworks like React, jQuery, Angular, Ember, so that it fits within your architecture in the projects you're currently working on. So yeah, they're available from our website, or you can even Google them and just download and integrate them into the project. And there's a easy configuration, so you just basically put in your token, and then you're ready to go. Then the plugin or module will handle the rest for you. WordPress is slightly different because it's not a sort of development framework. It's a publishing system. So the WordPress plugin is available in the plugin repository. Yeah, it also comes with a few options that you can tweak and optimize, but it should be sufficient to just download and activate it, and all your images on your block will be pulled through ImageEngine and optimized.
Great. So let's move on and quickly go through some of the other reports that we have. We looked at the iPhone trends that over a longer period of time in this last report. And in 2014, Apple launched the iPhone 6